Hello everyone, my name is Lisheng He. This is a pre-recorded presentation for the 2021 meeting of the Society for Mathematical Psychology. In this presentation, I'm going to introduce a paper called Interactive Attention to Amount and Time Information in Intertemporal Choice. And this is a joint work with Sudip Patil, my former postdoc advisor at the University of Pennsylvania. First off, let's take a look at what intertemporal choice is. In standard lab experiments, intertemporal choice usually refers to the binary choice between a smaller sooner option versus a larger later option. And here's an example. In the first option, it is receiving $10 in 7 days, and in the second option is receiving $8 today. And over here, the first option receiving $10 today in 7 days is the larger later option, and receiving $8 today is the smaller sooner option. In the enterprise of intertemporal choice research, a lot of models have been proposed to capture how people make intertemporal choices. And we can broadly categorize these models into two types. The first type is what we call the discounting models. Usually, discounting models assume that people will assign a utility or value to each of the options under consideration. For example, for option smaller sooner option, for SS option, participants we are going to assign a value to the smaller sooner option based on the smaller payoff and the smaller delay, which is XS and the TS in this table. And likewise, people will assign another value to the larger later option based on the value of XL and TL. And then the decision is based on which of the two values are larger. And usually the larger value, the option with the larger value is picked. And by contrast, time as attribute models for intertemporal choice assume that people may make attribute-wise evaluation. And over here, in this standard intertemporal choice between small sooner and larger later option, participants will likely first evaluate, for example, the difference between the two payoffs, and to see to what extent the larger payoff, which is XL, is better than the smaller payoff, which is XS over here. And then likewise, people will evaluate the difference between the two delays. And the final choice is based on the trade-off between the payoff difference and the delay difference. And recently, we made a pretty large-scale meta-theoretical analysis of these models, and we collect a total of 27 intertemporal choice models, which we think is almost all the models, behavioral models that can be written into programs and algorithms and make precise predictions about choice behavior. And then we try to represent these models in a single framework like this, like a model space. And over here, you can see we have in this paper, we have three categories of models, which is our delay discounting model, interval discounting model, and a time as attribute model. But as you can see from the figure here, the delay discounting and interval discounting here are pretty close to each other. So in this present paper that we are talking about, we'll talk about later on, we do not distinguish between the delay discounting and interval discounting models. And as you can see, delay discounting models as a whole are pretty close to each other and centered around the center of the model space here. And time as attribute models, by contrast, sort of are distant from the discounting models, first of all. And then some of the models are dissimilar with each other too. For example, the model number 27 is pretty dissimilar with model 26. And so this is the from the behavior side. A lot of researchers have proposed those intertemporal choice models, and we will get back to this page later on. And recently, there has been some surging evidence for time as attribute models as compared with discounting models. And the early but recent evidence comes from the paper by Shelton and Reed on Psychological Review in 2010. in the paper called the psychology of intertemporal trade-offs. And here they argue that many phenomena we observe in intertemporal choice experiments cannot be explained by discounting models, but can be explained by an attribute-based trade-off model. And later on in 2014, they present more evidence to support the idea of this time as attribute model called trade-off model. And in the same year, Dye and Busemeyer proposed another attribute-based model, and they evaluated the model in a sequential sampling framework. And they also suggest that the time as attribute models can predict and explain human choice behavior and reaction time much better than discounting models. Then more recently, Amasino and her colleagues have published a paper on Nature Human Behavior in 2019, and the title is called Amount and Time Exert Independent Influences on Intertemporal Choice. And this paper sort of moved one step forward to further suggest that amount and time seem to exert independent influences. And obviously, they also present a lot of evidence supporting evidence for time as attribute models. And here comes the key question we want to answer here. Do amount and time really exert independent influences on intertemporal choice? Or alternatively, is a model that assumes independent processing of amount and time a good model for intertemporal choice? Let's take a look at an adversary example. In the example choice between X and Y here, X offers you $9 today and $1 in 7 days. And then Y offers you $1 today, but $9 in 7 days. As you can see that X and Y has the same amounts and same delays in the two options, but the only difference between the two is the pairing of amounts and delays. And if, suppose we process delays and amounts independently, then it seems that the decision maker is likely to be unable to distinguish between the two options. And this example sort of explores the obvious limitations of independent processing of amount of time in intertemporal choice modeling. And we argue that this is especially alarming under the evidence accumulation model, because evidence accumulation models assume that we accumulate the evidence from sequential sampling, from either memory or visual fixations, and then so independent processing of the two just do not allow the decision makers to distinguish between the two options. And then empirically, do we really process amount and time independently? And to answer this question, we want to take a look at some eye tracking data and to see what evidence is there. And the eye tracking data is from the first eye tracking data is from the Amasino et al. 2019 paper, and they designed some standard intertemporal choice tasks. So in their setups, they have two options: smaller sooner option and larger later option. In the smaller sooner option, the delay is always fixed, and the payoffs has 20 levels ranging from $0.5 to $10. And the larger later option has a fixed payoff at $10, and the larger delay has 7 levels ranging from 1 day to 365 days. And so, for example, we can see if the smaller sooner payoff will influence the processing of smaller sooner delay, which is fixed at today. And we can also see if the magnitude of larger later delays will influence the processing of larger later payoff. And here's an overview of the results. As you can see from, let's say, first take a look at figure A. So in figure A, the x-axis is the SS amount, which ranges from $0.5 to $10. And on the y-axis is the proportion of attention allocation for the SS delay. And as you can see, the proportion of attention allocated to smaller delay increases with SS amount. And this is true for both the primary experiment and the replication experiments in the in Amasino 2019 paper. And in figure B, we analyzed the tendency in the log later option. So in figure B, the x-axis is LL delay and y-axis is proportion of attention allocation to LL amount. And we find a very strong pattern too, that the attention allocated to LL amount decreases with LL delay. And the reason is that LL delay, or delay in general as an attribute, is an aversive attribute. And in C and D, we show similar patterns, but we use a slightly different dependent variable on the y-axis. So in figure C, the y-axis is the proportion of transition from SS amount to SS delay, and in figure D, the dependent variable on the y-axis is the proportion of a transition from LL delay to LL amount. So overall, on the group level, we show pretty strong evidence suggests that the processing of amount and time are not independent. Rather, there are pretty strong interactive attention allocation and the transition patterns in the eye tracking data. Then, what about the individual level? So the group level shows pretty strong evidence. What about the individual level? So to capture the individual level interactive attention, we set up a Markov model of attention dynamics, which at the same time control a lot of confounding variables. Before jumping into the equations, let's first take a look at what the situation looks like. So in a standard intertemporal choice between smaller sooner and larger later option, we have 4 pieces of information over here. And with these 4 pieces of information, if we assume some Markov property, we can actually model the whole information search process using the 4x4 transition matrix as shown here in the bottom, the 4x4 transition matrix. For example, each of the transition probabilities in the matrix corresponds to the transition probability from the column to the row. And then furthermore, we write each of the transition probabilities as a function of 9 different predictors. And due to time limit, I'm not going to introduce all of those 9 predictors, but if you're interested, you can pause a while to take a look at the function and the tables over here. And of our critical interest is beta 7 over here, which is the effect of ST-1 desirability on within option tendencies. That basically captures to what extent the searched information how the desirability of the searched information influence subsequent search of the information within the same option, which corresponds to our interactive attention tendencies. And then with the model setup and with very rich eye tracking data, we can estimate each of the 9 free parameters. And again, so we are particularly interested in beta 7, which corresponds to interactive attention over here. So we estimate interactive attention parameters on the individual level from the 2 experiments. And then overall, you can see that almost 90% of the participants in their eye tracking data, there is a tendency of interactive attention. And this suggests that at the individual level, the interactive attention tendency is also very, very strong. For interim summary, first of all, we outline why intertemporal choice modeling requires interdependent processing of amount of time as 2 attributes. And then we advance a Markov model of attention dynamics to estimate the interdependency at the individual level from the eye tracking data. And then We also made some additional analysis which I cannot cover in this presentation. For those of you who are interested in the additional analysis, please check the video description. And thank you for your attention.